Hey, here we are. Okay, so back again, another hour later, taking a break from the day job. Okay, so here we are. I'm hoping I'm not going to hit my OpenAI API limits. So let's just check that real quick. So if I go, just 1 second, let me just open up another browser tab. Okay, so this was our original prompt to ChatGPT. I just want to check my codex usage. So my 5-hour limit, I have 55% remaining. So, and then it resets again at 4:50 tonight. So that is in 2 more hours from now. So this is the thing that kind of worries me the most is when I authenticate OpenCloud with ChatGPT subscription, which is really nice. I get a ton out of $20 a month, including everything else that I use ChatGPT for. Weekly usage limit. So I just have to watch out for this 5-hour usage limit per hour. But it still says I have a ways to go. Okay, so let's check it out. So it says it's done. Yay! You asked for all context to be written. It's in VOLTTRON version 9, a demo of a real agent. Platform driver agent is scraping data locally to a CSV file. Let's see what it made. It says that it made it. So let's check it out. So it even made CSV file logs per device. Wow, pretty cool. Okay, so I'm just kind of curious, what is the new way of writing agents these days? Not the old agent creation wizard flow era. So, cool. Neat. Let's check it out on here. So these are the logs. We're tailing logs in VOLTTRON. So if you do a lot in VOLTTRON, you'd be using log. You'd be doing a ton of this. Is tailing logs and then looking at data. You get errors in here, so you see platform driver agent, BACnet proxy agent, and hey, look at there's my little bend CSV logger agent. So I wonder where the code is for this. So I think we should be able to even see the code. I don't even know. Like, I might have to look and see where did it even put that code. VOLTTRON data, BACnet. I wonder where the agent is. Where is the agent? Okay, here it is. So in this directory in Linux on the Raspberry Pi, VOLTTRON data, bend BACnet CSV logger. Okay, so this is what it made. VOLTTRON data, bend BACnet. Oops, there's my email. Hold up, got too many windows open here. So VOLTTRON data, bend BACnet, demo CSV logger agent. So this is it. Okay, this is the code. This is the agent code that it made. So it is. This is the onStart method to VOLTTRON agents. From what I remember, it's been a while. 110 lines of code that it made. So I think that it's scraping the message bus here in this is my device registries that was used to set up VOLTTRON. So this is a pend CSV function here. Where did it device publish, make a callback. So yeah, so here I think it is actually looking at the VOLTTRON message bus. So it is subscribing to the message bus and it's listening for CSV file, the data being scraped. So hopefully that makes sense. So it's listening for this on the VOLTTRON message bus. Maybe I can kind of, let's see. So VOLTTRON looked at this, there's kind of like a little visualization. I think that is kind of the most useful. So like this is like the message bus in VOLTTRON. You just have to imagine this. This is my Raspberry Pi. So we created a BACnet driver here, and then I think we're using, what are we using here? So we're using a driver, and then we created a special agent that is listening to all the messages flying around on the message bus. So that's what that is. That's what this represents, is data on the message bus, and then we're kind of listening to it as a topic. And then what it's going to do is just build a CSV file, CSV logs. Look at that. Metadata. Yeah, look at that. So it's, wow, it's scraping every 10 seconds. So it is scraping, it's going to create some enormous files, but pretty cool. It worked. Wow. Oh boy. Okay, so where else can we go with this? So I really wanted to make sure that it is backing up. Hold on 1 second, guys. So like, I want to make sure that it's backing up all of this to these tutorials that I'll put on GitHub as well. So it is, it looked like it didn't back up its, I don't know what this is. So it actually, this is markdown files. So it is actually, it's building its context for itself. So it's not exactly backing up the code, but it's actually building context. Kind of cool. So these are the commands in VOLTTRON. VCTL, I think that stands for VOLTTRON control, but we can run some of those. Cool, so it's making context of if another OpenClaw instance wanted to do this, perhaps in a real building someday. Oh yeah, here's the code. That it could just hit the ground running. It'll know kind of just what to do. Okay, so this is cool. So it's ask what I wanted it to do is back up everything it knows, everything that it learned so far. I want it to back up here so we can push it to GitHub and try this out in more places. Okay, so what can we do that's more advanced? So I'm going to tell it to next. Okay, so keep in mind that on our BACnet scan tool, which I've demoed 10,000 times on this BACnet YouTube channel, this is just a test bench environment. So this is VOLTTRON running. This is my fake air handling unit with the points that it's scraping, and then this is a fake VAV box. So we could, I'm gonna go here. So this is one of my other creations, the Niagara Vibe Code Addict, where it's mostly my 2025 experience vibe coding Niagara platform, where I can put Java inside of some widgets in the Niagara framework. And I did a ton of Guideline 36. So these are pre-built wire sheets below, where this is a duct static pressure reset algorithm, supplier temperature reset, and then this should be another Java widget for VAV box programs, and then it's all linked. So these should be linked to here for cooling requests, pressure requests, and the little Niagara block can only handle 4 inputs. So you have to chain them all together, but all the VAV box programs do cooling requests and pressure requests, and then these all get cooling request total and pressure request total get fed into the duct static pressure reset algorithm and temperature reset algorithm. And there's some other points that get linked up for outside air temperature per the spec of Guideline 36. That's for the supplier temperature reset algorithm, and then we just link up the status that the air handling unit is running, and then we output. These would be linked into here this way. Then these guys would be linked into here as input, and then we're outputting here duct static pressure and supplier temperature reset. So if this worked so far in this little experiment, let's keep going. Okay, so like I am going to have OpenClaw go here. Actually, it's just going to have to go through here directly. I thought these were a link, but they're just drop downs. So I'm going to have OpenClaw read this in. Okay, so let's do this. Where are we? Okay, so we're here. So OpenClaw, I'm just going to say, good job, friend. Next, keep on documenting context. This is great to the same location on this Windows PC I have something copied already. I don't want to copy over vibe code apps 6 directory. Try this out. Go here, which is the Java version of GL36, and make an additional agent for GL36. And then we need to tell it so these test bench devices are AHU and a VAV box. So go through the Java code on those from the link and create Python versions for in a VOLTTRON agent form. Just demo VAV box request. Well, maybe we should do more demo. Make a VAV box request counting agent where then the VOLTTRON config file can take in as many VAVs as possible in an AHU system, and then a separate agent for the AHU. And I'm going to say make a robust tutorial for what you found that worked well, and please document that the code works with no errors in the VOLTTRON logs. Great job. Keep going. Also document, which I want to do this, very important, also document how AI can automatically know what points to use on a VAV box and AHU in any system, where we could create some sort of knowledge graph for the systems. So bonus points if you can factor in knowledge graphing in typical brick or 223p format, or DB, or whatever you like the best. I like brick and haystack fast where it may be neat to demo all of them if it is okay. Great job. Keep going. Make sure your context is really backed up well to do this elsewhere for any OpenClaw instances. Cheers. Okay, so cool. So this will be really neat. So we're gonna ask OpenClaw to keep going. So kind of like a little bit more about this. We could possibly even see. So that's the VOLTTRON. We could even try. I don't know what it named its virtual environment. We might have to ask. When OpenClaw is done, like how to do the commands. You can list the agent commands like the vctl status, VTL. You can start, stop agents. You can do a lot of cool things. So we'll just have to be able to know like how to manage these VOLTTRON agents when we're done. So obviously people that are VOLTTRON experts are going to be much more powerful than I am at this. So I only know just enough to be dangerous on this level, but you could even be setting up building to cloud pipelines if that's your expertise. So I don't know, this is pretty cool stuff. So let's see if OpenClaw can build a really cool Python VOLTTRON agent, copying the Java code in converting Java code to Python, working Guideline 36 sequences for air handling unit systems. Let's see if it can turn it into VOLTTRON agents. So fun stuff. Hoping you guys are liking this. I will probably see what it just finds in the morning and record another video. So hope you're having a good day. Talk to you later.